Well, the question ends up being is that how do I know when two functions are inverses of each other? How do I know when I have the inverse? And can there be functions that don't have inverses? And the answer ends up being yes. And the issue with the inverse function is this. The reverse path, now I'm going to use some mathematical terms, must be, and what I'm going to call it is well defined. The reverse path must be well defined so that if we know x goes to y, there must be only one way for y to return to x. So that if I were looking at a situation where 3 went to 4 and 4 also went to 4, I'm looking going from x to y, that is a function, that's not a problem. However, if I'm trying to return, I'm looking at that and saying 4. What does 4 to return to? Well, that's the problem. It can't return to both of them. It's confused. It doesn't know whether it goes back to 3 or whether it goes back to 4. So that's what we mean by the reverse path must be well defined. You have to know what you're going back to. You know how you got there. The problem tends to be when you go back, you don't know where to go back to. It's like having your return trip ticket and it says, okay, you're going back to Phoenix and Las Vegas. Well, you might want to, nice to go back to Phoenix and Las Vegas, but it says you're going there at the same time. That's not possible. Well, it is if you have a split personality. You know, one of your personalities could go to Las Vegas and the other personality could go to Phoenix. But normal people aren't quite that way. 4 can't return to 2 places. It can only return to 1. That means if I know that 3 goes to 4, 4 had dang well better return to 3. Now, what does that mean to me? That means that f inverse of x is also a function. So if I were to look at 4 returning to 2 places, can't happen. It's got to be a function, both directions. So f of x is a function both ways. Now, what we say is this: a function must be 1 to 1. Now, we used to get into these arguments over at ASU when I was teaching over there with the teaching assistants who'd say, what do you mean? Isn't this redundant? A function is 1 to 1. And now you're saying, well, a function must be 1 to 1. Well, here's what it implies. A function implies something. A function implies 1x to 1y. That's going across. 1x to 1y. If I'm talking about a 1-to-1 function, putting 1-to-1 together with function means this: 1y to 1x. It is narrowing down the group of functions. When we originally talked about functions, we said that, oh gee, we have this big thing called relations. And then we're going to pull a set out of relations that have this special property. They are 1-to-1, 1x to 1y. We call them functions. Now what we're going to do is we're going to pull a group of functions out of the functions that are now 1y to 1x. And we're going to call them 1-to-1 functions. 1y to 1x, 1x to 1y. And if you're taking a screwy little class called abstract algebra, they have a special name. They're called isomorphisms. It's the strongest statement you can make in mathematics of something which is an isomorphism. And it says 1x to 1y, 1y to 1x is absolute. So it's absolute. It goes directly back and forth between the two. Doesn't go anything else except it goes back to where it came from. Now, how do we know whether a function is a 1-to-1 function? Well, that says 1x to 1y. That's the horizontal line test, so a vertical line test. Vertical line test establishes a function. This means 1x to 1y. We have something new we're going to call the horizontal line test. Horizontal line test is going to be 1y to 1x. One y to 1x. Now, if I take a look at the first picture, I could do a horizontal line test. That means I choose an x value. So this is an x value. It only intersects in one place, so this guy is a function. Horizontal line test says this: you take one y value. If it only intersects the graph in one place, it's a 1-to-1 function. And you notice it only intersects this line in one place. This guy would be a 1-to-1 function. Function implies it passes the vertical line test. 1-to-1 function means it also passes the horizontal line test. This guy is a function. He passes the vertical line test. Pull an x value, only intersects once. However, if I pull any y value, there's the y value. How many times does that intersect the graph? Twice. So that's when y goes to two x's. So it is a function, but it's not a 1-to-1 function. A 1-to-1 function. Again, this guy is a function, but if I pull a horizontal line, what do you notice? In this case, it's 3 places, right? So it's not a 1-to-1 function. That means these guys don't have an inverse. They're functions, but they don't have inverses. Now, I could define, by the way, this guy to have an inverse. And what I do is I restrict the y value, the x values, so that x is positive. And if I say, well, if x can only be positive, then I get half of the graph, and then it passes a horizontal line test. That's called, by the way, a principal branch in mathematics. It says you could pick a piece of that function, which then becomes a one-to-one function, and then you find the inverse of that, and you say, well, at which point it can have an inverse, but only for x is greater than 0. And here, of course, it passes the vertical line test. It also passes the horizontal line test. So this is a 1-to-1 function. There are functions, and that means that this one has an inverse, and these two, they don't have an inverse, at least as they stand, and this guy has an inverse. And it's not as if that we have to worry a lot about that in this class.